All right, stats. So finally, time to do some significance test work. So this is the warm up for the true significance test section on proportions, but we're going to test the claim about a proportion. All right, so let's take a look at the first objective. Oh, it's the conditions checking, which we've done for the last two chapters. So if we're going to work with proportions and do a significance test, we have to check two conditions. The first condition is the random condition. Does your data come from a random sample from the population? Number two is the large counts. Now notice here the notation, n times p null. That p null is your null proportion. So again, that's the given value, right? That's the value you use in your hypotheses. So keep that in mind. But again, have to have at least 10 successes and 10 failures. Okay, cool. Easy peasy. All right, here we go. So, is the drive-through fast? So, the manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food after placing order. I think this sounds familiar. Based on store records, the proportion of customers who had to wait longer than 2 minutes was P equals 0.63. To reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. The manager would like to carry out a test at the alpha equals 0.10 significance level of the null hypothesis P equals 0.63 versus the alternative hypothesis P would be less than 0.63, where P is the true proportion of drive-through customers who have to wait longer than 2 minutes to receive their food. During the next month, the manager collects data on wait times from a random sample of 250 drive-through orders and finds that only 141 of the customers have to wait longer than 2 minutes. Check if the conditions for performing the significance test are met. All right, so here we go. Our conditions here. The first condition is the random condition. So I saw right here, random sample of 250 drive-through orders. Random sample of 250 drive-through orders. So that's good. Number two, large counts condition. So first, do I know my n value? Well, I just wrote it down. It's 250. And do I know my p null value? Again, the I'll make it bigger. The number used in your hypotheses is the null value, 0.63. Now, you might have said to yourself, well, shouldn't I calculate this 144 divided by 250? That is your sample proportion, p hat. We're not doing that, okay? We're not doing the last section or the last chapter where we use the sample value. We are going to work with the null value, okay? The null value, so 0.63. Okay, so we'll do n times p null. So 250 times 0.63. When I do 250 times 0.63, I get 157.5, which is at least 10. And when I do 250 times 1 minus 0.63, I get 92.5, which is at least 10. All of my conditions are met. And there we go. Okay, same kind of idea as we've been doing. All right, so there's your conditions checking. Objective 2 is coming where we have to find our z value.